Hey, hello and welcome to today's GFG problem that we're uploading. Well, so let's say today's problem K sum paths. Okay, so what the problem is saying is we'll be given a binary tree. Okay, and we want to find out all the downward paths, downward only paths whose sum of the nodes equals given K. Okay, so what are those paths in this example? So one of the path is this 4, 2, 1, right? If you see 4 plus 2 plus 1, the sum is equal to K, and this is also downward only path. Okay, then we have another path which is 5 and 2, right? Whose sum is equal to K. Then another path is this particular one, right? 4 and 3, okay, whose sum is equal to the given K. So there are three paths, okay, and hence we want to return this particular 3, which indicates the number of downward paths whose sum is equal to the given K. So this is a problem. I hope you have got the problem. Now let's go towards the approach, okay, how we going to solve. So I'm trying to going to make it very easy for you. Just one request to please subscribe to the channel, like the video. Okay, so let's quickly see. So what we're going to do, we're going to have a paths list, okay, or vector, okay, and we are going to add the element as we iterate, right? As we iterate, we're going to add the nodes element into this particular path, okay. So currently we are on 8, we're going to add 8, okay, and once we add the element, we're also going to run a for loop, okay, that is we are going to iterate the elements from the last element to from right side to left side, okay, and we're going to keep on adding the elements, and we're going to compare whether the sum is equal to the given K. For example, here it is only one element right now, so the sum definitely it's 8, and it is not equal to the given K. So what are we going to do now? We are going to go to the left, okay, we are going to go to the left. Now there's 4. We're going to add 4 in this. Again, we are going to iterate from right to left. We're going to have sum 4 plus 8, right? 4 plus 8. The sum is not equal to the given K. So we're going to go to the left, okay, which is 3. Now we're going to add this 3 into the list. We are going to run the follow from right to left. Okay, now 3 plus 4. Okay, 3 plus 4, it is 7. Definitely it is 7. So we are going to compare with K. Yes, it is equal. Okay, so we are going to have a variable output which indicates the number of paths, right? Whose sum is equal to the given K. So we have found one path. We're going to add one here because 4 plus 3, right? We found one path, which is that one, this particular path it is. Okay. Okay. Now we're going to go to the left. Before going to go to the left, right? We will keep on adding the elements, right? We're going to keep on adding the elements. For example, why is there a meaning to once we found the path? Is there a meaning to go still to the add the elements, right? Remaining elements till zero. Okay, till zero the position, and to check if the given sum is K. Yes, it is, because for example, if this was the case, for example, if this was the case, plus if the elements were 2, minus 2, 4, and 3. Now we had found one path here. Now, is there a meaning to go and add the elements further? Okay. Even if you have found the path, yes, definitely, because of this case. So now 4 plus 3, it is going to give us what? 5. 4 plus 3, 7, minus 2, 5. And again, if we add this plus 2, okay, it will be 7 again. So we could have found one more path. Okay. And that is why we are not going to stop, we will keep on adding. So here 4 plus is 7, 7 plus 8, it is 15, okay, which is not equal to K, and hence we're going to stop here since 8 was the last element. Now we're going to go to further left, which is 3 now. Okay, we're going to add 3, and we are going to compare 3 plus 3, is it equal to K? No, it is not. 3 plus 6 plus 4, okay, which gives us 10, is it equal to K? Then 10 plus 8, further 18, is it equal to? No, it is not. So there's no path here whose sum is equal to the given K. Now, what are we going to do? We're going to go to the left of 3. There's no element, there's no child, we're going to return. We are going to go to the right of 3. There's no element, we're going to return. Now, we are done processing the left subtree and right subtree of this particular 3. So once we are done with any element, right, processing its left subtree and right subtree, we are going to erase from the path. Okay, that's what we have done. Now we're going to go back. We're going to go back. Now we are going to go right. Okay, so we went right here. It is minus 2 over here. So we're going to add up this minus 2 in this particular paths list. Again, we're going to run the follow from the last element. We're going to calculate the sum. So we won't find, are we finding 3 minus 2, 1 plus 4? No, we are not finding any paths here, right? So we're going to go to the left. No, there's no element. We're going to return, right? No element, we're going to return. And finally, we're going to pop this 2 out. We are going to go back. Before going to the back again, we are done processing the left subtree and right subtree of this particular 3. So we're going to pop this element out again from the paths. Okay, now we go back to 4. Now there is still right subtree to be processed of 4. So we're going to go to the right. We are going to add 2 here. So now let's write this list again. What are the elements here? 4, 8, 4, and 2, right? We're going to run the for loop. We're going to calculate the sum. 4 plus 2, 6, which is not equal to given k, plus 8, which is 14, which is not equal to given k. Okay. So now we're going to go to the left of this particular 2. No, there's no element. We're going to return back. We're going to go to the right of this 2, which is 1. We're going to add this up in our list. So this is 1, right? This is 1. Again, we are going to calculate the sum from the last. So 1 plus 2, 3 plus 4, which is 7, which is equal to the given k. And hence we have found on our another path. We're going to update the variable. Okay, we'll keep on adding this 8, 7 plus 8, 15, which is not equal to given k. And we are going to stop here. Okay, now, now comes this particular one, right? So we're going to go to the left. No, there's no element. We're going to return, right? No element. We're going to return. Okay, and we'll pop this one out. Similarly, we are done processing the left subtree and right subtree of 2. We're going to pop this particular element out. Okay. Similarly, we are done processing the left and right subtree of 4. We're going to pop this element out. Okay. Now comes this. We are done processing the left subtree of 8. Okay. Now we are going to go to the right. Okay. We are going to add. Now what is the elements in the paths hold? 8. And now we are going to add 5. Again, we're going to run our for loop. Okay, we're going to run a for loop, right? Which is again, there's no sum whose path whose there's no path whose sum is equal to the given k. We're going to go to the left. No, there's no what do we say? There's no child. We're going to return. Now we're going to go to the right. We're going to add in the list 2. Okay, now we're going to run iterate to the for loop again for the last element. We're going to calculate the sum. We got 5 plus 2, which is 7. We have found our another path. Okay, in this way, this is the intuition behind solving this problem. Okay, I hope you have got the intuition. Now let's go and code. I think you'll understand better. Before going to the code, I'll just request you please subscribe to the channel, like the video. Okay, so let's first implement the Java code followed by C++. Okay, so let's have our list paths, integer paths equal to new array list. Okay, then let's implement this utils function. Okay, root k and paths. We have void sum k utils node root int k array list integer paths. Okay, now what we're going to do? First of all, the first step is let's write the base condition. If root equal to null, then do nothing, return, just return, right? Otherwise, add paths dot add. Whenever we come on a new node, just add that particular node's value, paths dot add root dot data. Okay, then some k. What are we going to do? Before that, right? Once we add the path, we're going to have sum equal to 0 variable. As I said, we are going to iterate the paths, right? From the last element to the first. Okay. Int I equal to paths dot size minus 1, I greater than equal to 0, minus I. Okay. Sum plus equal to paths dot get I. Okay. I'm going to compare if sum equal to k. We are going to have a variable. Let's have it global int, a class variable int output equal to 0. Okay. Now what are we going to do? We have found a path, increment the output or the number of paths variable. Okay. Once we are done iterating, so here we are not stopping again, right? We are not breaking out of this after this if, right? Inside this if, we are keep on adding. I have already explained you the reason for that. Okay. Now what are we going to do? We are going to go to the left child as we have discussed in that dry run, right? Root dot left k and paths. We're going to pass, right? Similarly, root dot right. And then what we're going to do? Paths dot remove paths dot, we are going to remove the last element, right? The last element, since the last element or this particular root, whichever is the current node, okay, whichever is the current node, we are done process the left subtree, the right subtree. Okay, now it's a time to remove that particular node also from the path. Okay, okay. So let's one more step, return output. So let's compile this. Let's see. Okay, let's submit. Thanks for watching. Please subscribe to the channel, like the video. Okay, the test keys are being processed. Okay, thanks for watching. Let's quickly see the C++ code as well. So here is the C++ code. We have this paths, right? We have this utils function. Okay, this is a base condition as I've already explained. We are adding the element here, element value here, the node value here. Okay, we are running the iterating through the paths. Okay, from the last, we are calculating the sum. We are comparing with k. If it is equal to k, we are incrementing the output, and we are going to the left subtree, the right child or the right children or subtree. Okay, and once we are done processing the left and right subtree, we are popping the last or this particular current node or root, whatever you call, from the paths. Okay, that is we are backtracking. Okay, so thanks for watching. I'll attach a code in the description section. Please don't forget to subscribe to the channel and like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.